Okay, now we have a sample problem here on the board. Of course, the question states a force of 12 Newton is required to stretch a catapult of volume 3 meter cube by 15 centimeter. Calculate the force constant of the rubber of which the catapult is made, and the work done in stretching it. Also calculate what? The energy density. So the concept is easy. First of all, we have to write our given parameters. So what are we given then? Of course, we have to read this question again, and we have a force of 12 Newton. So therefore, our under solution, we are given force as 12 Newton, and we are given a volume of what? Um, 3 meter cube, and an extension because of the say is stretched is required to stretch a catapult of volume 3 meter cube by 15 centimeter. So therefore, stretched and extension are the same thing. So therefore, we have an extension at 15 centimeter. And they say calculate the force constant, which is what you can say in terms is the K. So the force constant is the K. We're looking for that. Also, they say you calculate the work done. Of course, we're looking for work done. And the last, say you should calculate what's the energy density. Energy density. So let's donate the energy density by U. So the concept is easy. How do we solve a question like this? Of course, the first step is to calculate what? The force constant. So for K, which is the force constant, we say that F is equal to what? Ke, right? And we have the value of the extension, we have the value of the force. But before we do that, look at our given parameters. Are they in the right proper units? The answer is no. Of course, we know that extension is measured in meters. So why is this in 15 centimeters? We need to convert 15 centimeters to meters. Of course, the concept is easy. To convert 15 centimeters to meters is the same thing by dividing by 100. Of course, we have our answer 0.15 meters. To check that, we have 1, 2. So we have 0.15 meters. So therefore, this becomes a 0.15 meters. So therefore, we make a use of the formula. We have F over E, and our force of what? 12, and the extension is what? 0.15. So when we punch this, we have that's 80 Newton per meter. So therefore, this is the first constant, um, of the rubber to which the catapult is made. Now, the second one to look for what? The work done. Of course, using the relationship of what? The work done in relation to what? The stiffness of the material, which is also known as the force constant. So, in relation to that, see, we're looking for work done. So, for work done, we see work done is given by what? K e square over 2, right? And if we substitute this, we have 80 multiplied by 0.15 all square over 2. So we have the work done at 0.9 joules. So the work done is 0.9 joules. And another thing to note, we say you should calculate what energy density. What comes to your mind? Now take down. The concept is easy. Normally we know that density is what? Mass over volume, right? Which is mostly mass density. Energy density is the same way. So energy density is the ratio of what? Energy to volume. So we have it denoted by U, of course. U is equal to what? The ratio of energy to what? Volume. So therefore, we have our energy density as what? 0.9 divided by the volume 3. So therefore, this becomes what? 0.3 joules per meter cube. So there is the concept of energy density. So thank you very, very much for this video. I urge you to smash that like button and also subscribe and turn the notification bell on so that you will be notified when we drop new videos. Thank you very much.